All right, guys. I think I have everyone is able to download the content, the latest changes that I have shared. Please confirm if everyone has able to download it or still anyone facing any issues. Let me know. All right. Okay. Thank you. Thank you for confirming. So, as we know that in previous sessions, like we discussed about the Prometheus flow, like how to set up the dashboards and observability part as well we covered. And we have gone through some couple of use cases related to the production issues that we discussed about the routing mechanism, how the rules works, alerting works, and whenever the targets and the applications are down, how the respective teams are getting called out, right? We discussed about that part. Apart from that, we have gone through the incident blameless postmortem process, like incident management and blameless postmortem, the complete flow about how to handle the incident related to the severity 1, severity 2, how to prioritize them, how to analyze the incident, and based on that, uh, how to engage the respective teams and all we have discussed. The roles of respective teams. We discussed about the incident commander, the ops team, and their roles. Right? We have gone through all these cases last week. I have also shared the content. If you have gone through it and you have any doubts or any queries, just feel free to let me know. We can discuss. Else, like we will proceed with today's demonstration. Okay, right. All right. So, in today's session, like mostly we will be covering the Prometheus and Alert Manager, their connectivity, how they interact with each other, how, as we know, like the pull mechanism at the Prometheus level, and how that push to the Alert Manager, and we will see how the rules are getting triggered at the Alert Manager level, and how we are grouping all the alerts and how to avoid the noise in the application. Let's say there are multiple applications are having the same issue, and instead of, let's say, the 50 servers are there, so instead of 50 alerts, how we can group them in a single alert rather than spamming all the um, like the alerting mechanism, right? So we will work on that part today, and what exactly we can optimize the overall alerting flow and how that improves your overall observability and the call out process. Okay. So before we deep dive into the complete process or start with our lab, I would like to explain you few things like over here. Let me know if you are able to see the complete architecture. If you still want me to increase the font, I can. Okay. So we have been discussing about our payment app, right? So we have created dashboard, and we have tried couple of with Loki as well as the Prometheus metrics. We have created some dashboard last week, right? With importing the JSON files, and we were able to uh, create the chaos scenarios, incident scenarios, right? So the same example we will be having. We'll continue with that. So what we will do in this week, this session, like we are mostly focusing on this alert manager process. Okay, how this alert manager, what's the exact role of this alert manager over here, and how it is different from the pull mechanism. Okay, and how they call out to the respective teams, and yeah, we will discuss about that part, right? So as you can see, the payment API container, we have this container running with the 8080 port, and we have this logging mechanism as well, right? So we have exposed the metrics, and with the Loki we have exposed the logs as well, right? So at the Prometheus server, as we know, this is the time-based database, and it is scraping the data in every 15 seconds, correct? And it um, from the payment type it scrape, it pull the request once your target is up. Usually the Prometheus server pull the required details from the respective servers, from the nodes and the exporters, correct? And it is storing into the TSDB database at the Prometheus level. So from here on, how exactly the Prometheus server works and how it computes the overall error process, right? It is not like for the Prometheus server, as we know, the mechanism is not only storing the database and to handle the complete log mechanism or metrics. Apart from that, mostly the Prometheus server computes the data based on based on the logging mechanism or the rules that we have written, and based on the rules it usually triggers or it fires the alerts, and it pushes the notifications to the alert manager. So that is again a critical functionality for of the Prometheus. So that's why, like, if you have seen the rules.yaml that we have written, we will go through it um, step by step. When the YAML file, we'll go through it. But like this Prometheus server computes the rules that we have written, right? And based on that, it pushes the alerts to the alert manager. If the Prometheus server is like able to, so if that activates most of the times, these rules are inactive when your system is running fine, correct? So as and when your application has some issues, or there is a spike, or there is a latency, or there is an error rate is increasing, these rules will be get activated. It will go into the pending state first, and then the timestamp, whatever the timestamp we have given, the seconds, right? The 30 seconds time we have given. So it will check in after 30 seconds again. If it is still seeing the issues, then it will get into the firing mode. Then it will inform to the respective teams. Correct. So again, this recording rules are there. It's again a functionality of the Prometheus server. When it comes to the rules, right? So we have this rules.yaml file. So we will be performing this to today's labs. Like, we'll set up our own rule with the lab that already we have built in, right, for the payment application error rate. So similarly, we will have one or two more alerts, two more rules that we will set up. If we notice that if the error rate is more than 2% in a 1 minute of window, then this alert will get activated. Similarly, for the slow request, if we notice that the latency of the application is more than 400, then this lab slow request alert will get activated. Okay. Once these alerts are get activated, it's kind of a push mechanism that your Prometheus server send push alerts to the alert manager. And based on the branching and grouping that we have done at the alert manager level, based on that, the alert will get triggered. Okay. So will discuss about the grouping mechanism today. What exactly the inhibition rules and how the suppression engine works. Correct. We'll perform this step by step with the lab, and you will get to know better once we implement the inhibition rules. Apart from that, we will be discussing about the routing trees mechanism, how to route, like how based on the criticality, how this alert manager routes the alerts based on the rules that we have set up. If it is a critical alert, what exactly need to be performed, and if it is a kind of a warning alert, what exactly the steps that the alert manager should do. In which case, we should get notified over the call or over the pager or over the MS Microsoft Teams, and in which cases, like, we should be getting the payments ticket. Correct. So if you remember last week, we discussed about the severity 1, severity 2, and severity 3 incidents, right? The type of the incident, and based on that, we need to set up these rules. So last week, if you are aware, like, mostly we have covered about the theoretical part, like what exactly the core concept behind setting up the alert or prioritizing the incident. So based on that, that is again the baseline for whatever the things that we are implementing today. Correct. So uh, still, like, if you still have any confusion or doubts over the last week discussion or the case session, just let me know. We will discuss on that, and then we can proceed. All right. Once this routing is completed, like, let's say your alert manager. So this is nothing but your alert manager, how that notifies to the next, like, at the end user. So who is the end user here? So there are two types, like If it's a kind of a critical alert, then the on-call engineer will be called out. Correct? It's a severity 2 or severity 1. If it's a kind of a severity 3 related incident, where that issue can be checked in the business hours. So in such cases, it will be opening the incident on your behalf, kind of a P3 level incident, and that incident will be assigned to your team. So this kind of routing of the alerts. So that also part we will discuss, and how that works internally, where we no need of any manual intervention. These are the complete rules and routing process that we have to implement, and once it is in place, you no need to define any additional rules, or you no need to work on any creating a incidents or creating the routing mechanism again, or any, there isn't any manual process involved, right? So so that is the complete process. Mostly we will not be focusing on the Grafana, since like the mostly today's agenda is on the alert manager, right? And how the alerts are getting triggered at the endpoint, how the receiver will get notified. Based on that, we'll see how that works whenever we see any kind of chaos mechanism or any issues in our application. Okay, so far so good, right? Please confirm. Everyone, hope I'm audible. Please confirm, give me at least a thumbs up or any acknowledgement. All right. Okay. Perfect. So moving on to the next part, let's start our lab. Okay. So I have already shared the SRE lab, right? So you can start fire up your Docker engine. Okay. And let's open the prompt. You can open the Git Bash, or I'm using Git Bash. You can try with PowerShell as well. Okay. And we no need to trigger any compose build as of now. Like we have one script over here, lab.sh. So in that, like we already implemented all the things. Like we no need to fire up all the containers, since today's demo session we don't need of the Grafana instances. So we only bringing up the required containers. Okay. Yeah. So as you can see, we have a couple of scripts files over here, correct? Lab.sh, verify.sh. So we'll start with the lab.sh first. Okay, so just enter lab.sh and check, execute this command. Okay, sh lab.sh. That will give you what all kind of containers required for today's session. Okay, so based on that, we can run the Docker command. We no need to start all the instances, like for example Loki and all instances are not required, since our mostly focus will be on the alert manager, right? So I will be running this command. Okay, the docker compose profile logs, right? So that will build all the containers. I'm using that command over here. Just execute the same as it is from the SRE lab directory. It will take some time, and as like today we have almost like 8 containers to start, so it will take some time. Now it started. So you can check once your containers are up. You can check if the instances are running fine or not. Let's check that out. Yeah. Docker compose ps. So I brought up a Loki instance as well, since I need to perform a kind of target down operation, right? So though we are not using this instance actively, we will use it to check if the target node alerts are getting triggered or not. When we bring down the Loki instance, we should be getting the alert in the target in the alerts, right? So from the Prometheus alert. So we will check that if it is getting triggered or not. So for that purpose, we will be using it, but not mandatory. You can bring down the other instances as well to test. Okay, please confirm once your containers are up and all these instances are running fine. Then we'll quickly validate the alerts and all. So let's take that out as well. So for Prometheus, we are using 9090, right? So let's check that out. Please check with the localhost 9090 alert if uh, if you are able to access the Prometheus alert. Let me use that command as well. And in today's section, we have this alert manager as well. Let's check the alert manager localhost 90. What's the port we are using for alert manager? It's 9093, right? You can check the ports with the Docker compose ps, correct? So you can let's try to access the localhost 9093 as well. This is the alert manager prompt. The As you can see, this is nothing but the alert manager instance, correct? Whatever the groups or filters that we will apply for the alerts, that those will be displayed over here. So as of now, you don't see any kind of groups and anything, right? So apart from that, we have one more instance running, correct? We have to check the console as well. This is the kind of console, as this will be this will act as a end user, right? Okay, so as you can see, this is kind of again a dummy portal. Okay, so as we cannot integrate with our app with the Microsoft Teams, so I will be sharing you the complete steps like how you can integrate your alert manager from alert manager, how that can be integrated with the Microsoft Teams. Okay, but now you can just try to access with the localhost 9095, and this is nothing but the same window will be, I mean, the same alerting will be implemented on the Microsoft on Microsoft Teams or whatever the alerting channel that you are using there, though it could be a PagerDuty, could be Slack. So based on that, you can configure. So in our configuration file, I have given the steps to configure it on the Microsoft Teams. But this is a kind of a portal where you will be able to visualize how these alerts will get fired. Okay, so just try to access localhost 9095 as well. So just remember these three localhost prompts as of now. One is the Prometheus one, the Prometheus server, correct? That is nothing but like this server is going to push the alert to 9093, and the 9093 is again going to push the alert to 9095. Hope the flow is okay. You're able to understand the complete flow that we have discussed in the architecture diagram, right? So it's the same flow we will be implementing. Prometheus server that will be firing, or that once that alert is get fired, if you can see here, most of the alerts are in inactive state. Once these alerts are get fired, it will notify the alert manager. The alert manager will notify to the respective end user. It could be Teams or whatever the app that you are using for your day-to-day communication. Please confirm if all these localhost URLs are working for you and you are able to access them. Perfect. All right. So let's get started with our first session, guys. I will quickly show you what all kind of files we have, and then we will implement it. Okay. We no need to rewrite it from the scratch. There are some lab in our SRE. What I can In the SRE lab itself, we have this lab directory. You can simply use the same. Uh, Let me show you that. Yeah. Okay. Okay. So, so these are the directory structure, right? As we have discussed in past about how the applications are connected to each other in Loki, Grafana. We are keeping this as the instance as it is, and in today's session, these three directories are added: uh, Alert Console and Alerting Lab. Alert Manager is been there, like we are already having this Alert Manager. Based on that only, we were able to see in past, like if the alerts are getting fired up or not. Correct. So let me quickly show you like what all configurations we have done over here. So starting with the Prometheus server, okay. So in Prometheus server, what we have done, okay, let me add. You can open the Prometheus YAML file, guys. Yeah. So as you can see, this is the standard script interval that we have set up, right? 15 seconds of standard script interval, and every 15 seconds, the Prometheus server is going to pull the records, correct? The alert manager, the alerting that will be pushed to this alert manager with the port of 9093, correct? And the rule filters that we have set up, the Prometheus server is going to access the rules that are implemented over here. As you can see, we have rules.yaml file, and we have rules.d, a directory in that we are accessing all the YAML files. Okay. Uh, Mostly whatever the lab sessions that we will be doing, we are not going to touch the actual production file, or what we can say the standard running file, okay, from where the currently the rules are getting triggered. Since our Prometheus server is also pulling the rules from the rules.t and the YAML file, right, inside this. So if we are like, let's say whatever the changes that you have done, if you do the same on the by default, if you implement the same or you change anything at the rules.yaml file, and if there are some kind of indentation mistakes in that, and or any kind of extra spaces or anything that you have written which is not getting recognized, then the complete rules will not be the rules will not work. Whatever the rules YAML dot you have set up, they are not going to work. That's why whatever the always the things are like these things are recommended. Even though you are configuring this on the production environment, it is always recommended that whatever the standard working functionality is there, you do not touch the or try to modify the existing working process. Create your own YAML file based on the functionality or based on the requirement. Okay, fair enough. Okay, guys. Okay, thank you. And as you can see, the configurations that we have set up, the standard configuration, the target nodes, they are node exporter, they are configured on the 9100. Our payment app, that so all this script config, like from what all servers our Prometheus server is going to pull the request, the records. So these are the configuration target configuration that we have set up, correct? So whenever there is like a target issue or any kind of issue, you need to make sure that whatever the target you are configuring, that entry is added over here. All right. The next file is yeah, I was discussing about the rules.d, right? Here you could see the all lab 1 lab 6 files are there, right? So once we as of now, our Prometheus server is not able to read that, since the file format is not, it's a kind of example file, right? It's not a YAML file. That's why the Prometheus server is not able to, won't be able to read it. Even though if you see the rules that we have set up, it won't be able to read it. Okay, so just to start with the today's first session, like the rule that we are going to implement. I hope everyone is clear about the flow, the localhost entries, and everyone is able to access the required pages. So 9090 alerts, 9093 is the alert manager, and 9095 is the console, who actually get notified with this alert. I hope everyone is able to access these endpoints. Anyway, like Grafana is also also working for you, but as of now, we mostly will not be accessing that. We're mostly focusing on this alert manager service today. Okay, and whatever the configurations you do in the Prometheus level and at the alert manager, we don't need to restart the container completely. It's a kind of a post a curl call that we are pushing, and the reload activity. Once this reload is done, those changes will be reflected on the Prometheus server and then the alert manager. Okay, so whatever the rules and routing changes you do on the file level, you no need to restart the container. Okay, fine. All right. So as we have discussed yesterday, just last week, just to give you the quick overview, we know that there's severity 1, severity 2, and 3 levels of the incidents, right? One is nothing but the complete outage, and whenever there is a complete outage, the response has to be complete a call out to the respective teams, though it is through the Microsoft Teams or direct call out to the on-call member. Everyone has to be online within a given whatever the window is there, OL is there. Severity 2, like mostly the degradation, significant impact, like the 10% of your members are already impacting. And in such cases, like mostly rather than calling out to the members, it's kind of the on-call member who is available, they need to be paged from the Teams or Slack, whatever the channel you are using. Okay, and that requires a dedicated response. Severity 3 is nothing but minor one, if it's a kind of not impacting to the member much, even though they would be feeling they are experiencing some kind of slowness or any issues with the application. In such cases, just raise a ticket rather than creating the paging them or alerting them at the midnight. Okay, so uh, we'll implement the same right now in the alert manager, and how that alert manager will get triggered to the uh, 90954 port. That is nothing but the Slack. Okay. Okay, so we have gone through this the rule how the rules are getting the YAML file, right? So just give you the quick overview about what exactly this alert rule is, right? So this like alert rule usually we configure based on the requirement, whatever the applications that you are supporting, and based on the SLIs, as we discussed about we need to find out the SLIs correct for your application. So based on that, you will come implement the create the dashboard and visualizations for your application, correct? So same, now the visualizations are in place, provided that it's working as expected. But somehow whenever you are seeing any kind of anomalies or any kind of abnormal behavior within the application, we need to be get notified rather than sitting on front of system for all 24/7. The system should work in a such a way that if I'm able to see that the error rate or the error ratio of my application is greater than 0.05 within 5 minutes, I should get a call out as a critical severity. Okay, so this is the nothing but the rule, the YAML rule that actually how on this complete YAML process, these features like these are the complete parameters will be used by the alert manager, and based on the criticality of the application, the alert manager will get triggered. All right. So let's start with the first lab. Okay. So as you can see in your Prometheus rules.d directory, you could see lab 1 YAML and lab 6 YAML, right? So just open the lab 1 YAML YAML file, and let's check what all details we have over here. Okay. So as you can see, uh, in the groups, like we have set up the groups, right? It will create a separate group for our project. The name is lab 1 interval every 15 seconds, and the rules that we have set up lab high rate. So if for my payment application, correct, if the total number of requests, the 500 requests in 5 minutes of window, if I am seeing that the uh, overall error rate of my application is more than zero point 0.2, correct, for 1 minute of check in every 1 minute, correct. If that is the case, then send me an warning alert, and the service name, it is nothing but we are checking for the payment application. We need to provide the service name over here, the team who is the who is responsible for this endpoint, the payments team, correct. We have discussed about the annotation as well. If the payment rate is more than 2%, whatever the exact value is there, that will be get described over here. The runbook is nothing but the process in case of such alert, what all steps to be performed. Apart from that, the same process for lab slow request. This is nothing but the second alert that we are going to set up. Correct. It is nothing but the latency of the application that we are checking. If the latency of the application is zero point 0.4, it is nothing but more than 400 milliseconds. If it is more than that, check for a 1 minute window. If it is still more than that, then labels send a warning alert. Uh, Severity is nothing but the warning, and again the team name and everything will be the same. Okay, and summary and everything will be generated over here. Fine. So simply what you can do, you can copy paste this into the rules.yaml file, but what I recommend, do not change the production file. As you know, this is the production file, right? Rules.yaml. This is the standard production file. So even if you are working the same on the production configuration, always create a separate directory where you can implement a kind of locking mechanism over here, correct. And based on the status or the like, let's say you are accessing this file, you can keep these files in a kind of a bucket where you can have implement the locking mechanism, and only one member within your team should be accessible at the time, correct. That's why it's always recommended that you should have a proper separate directories for the YAML changes that you are implementing. Okay, so what you can do over here, just close this file, the uh, application, this lab1 file, and rename it. Just keep only lab1.yaml file. Okay, just keep only lab1.yaml. Yeah. Everyone, please confirm once you are done with this change. Just simply we are renaming the file remote.example, and you will see lab1.yaml file. Okay, now since the Prometheus server has lab1.yaml, and we have in our alerting part, we have already in the configuration part, we have already defined that whatever the YAML files are there, please pull the records. Correct, we have already informed to Prometheus server to pull all such records, pull all the rules, right? So from the rules.yaml file. Now ideally it should pull all the records, right? But it won't, because uh, the Prometheus server is still running on the old instance. It is still using the old, I mean, it has not picked up the latest changes that we have done. So as I said, in such case, we have to reload the changes, correct? So let's reload the files, and let's see. So first of all, we have done the changes at the Prometheus rules, correct? So just run this reload localhost. Let me ping this command. Okay, please make sure that you are running the reload command once you are done with the updating the root.yaml file. Okay, then only update, otherwise the changes will not be picked up.
One question here.
Anirudh, you are saying something?
Yes, actually. Am I audible to you?
Okay, one second. Yeah, tell me.
Yes. So, I didn't understand here. You make a changes into the file that you rename the file. Okay.
Mm-hmm. Mm-hmm.
But in the containers that we have are running don't have that file, right? Then how it will be reload works here?
See, it's a kind of the container doesn't have these files, right? Somehow, like, see, the reload is nothing but a feature. Like we sometimes we do the push mechanism, right, to our application.
Hmm.
We forcefully push to take the latest changes to our application. These are the runtime changes. That is not the build kind of changes that they are built as at the file at the time of compiling the changes. These are the runtime changes like that you will do it. So there are some features, right, for your application, wherein instead of running or triggering the complete restart of the containers, some features that the YAML related changes where you want to push the changes rather than disturbing the complete service health. So in such cases, the reload will kind of send a kind of it will send a curl request, okay, to your application. So
So,
it's kind of already built-in feature for your container. So this reload, we check the Apache status, right? So Apache status, Apache start, Apache stop. So they are these already the scripts are already been written over there within your application.
hmm,
So when you trigger that, it will run that script internally.
okay, got it.
You getting my point? So we are not separately writing any kind of script. We are just hitting the container with the reload, where this reload feature is already been there in the container.
Okay, that is understandable. But what actually we have changes into our do modification into our local, right? When we run this particular command, -post, okay, reload wala stuff.
Mhm.
Then what is actually happening into the container? It will pull the changes into it. So our container
Hmm.
has that particular YAML file, which is renamed.
Correct. So whatever the changes instances as of now it is like the it has the old changes, right? So
Mm,
whenever you do the changes on like this example dot YAML file, you have changed it, right? So when you hit the localhost 9090 reload, this
mm.
Prometheus, whatever the changes are there, this reload will internally kind of it triggers the refresh internally, and that pulls up the latest records. So there are some features like if you remember, like if we have to get our static files when you upload any static files. So instead of restarting the complete that lobby or something, whatever, where your static files are there, there is an option called refresh, right?
Yeah.
Or we reload. Sometimes we do the reload from the UI. So internally, that is nothing but it is performing the reload only. It is
So this is
pulling the
a
static.
Docker feature or Docker Compose feature.
It's not specific to any Docker feature, Anirudh. It's kind of a server level. It's kind of a VM feature like that we have on every server. Like even if it is like a Linux server, even that also has this reload features. When it comes, it comes with that functionality. You know, it's not specific to any Docker. It's a kind of a built-in feature for your application.
Okay.
Sometimes if
Okay.
they are not applicable, if they are not running, then we will have to install them based on the application requirement.
Okay.
Let's say if you have the server where you are storing the mostly you are storing the changes related to the backend side, where those changes will picked up only when you restart the Apache container or Apache Tomcat container. In such
Right.
cases, you no need of this reload feature, right? Since even after the reload, your features are not going to pick up. But there are some static servers where you are not storing the application, the Java instances or any instance, where you are simply storing the static instances, right? Wherein like you no need to run the complete container for that particular feature. So what you can do, you can simply have this reload feature available, and this reload will be once you perform the reload, only the latest assets will be refreshed from that container.
Okay. Okay. So container will pull the changes from the our local, correct?
Correct, correct. It will be, see, whatever the changes we are doing, it is going to pull it from our local only. That's why we are doing the local host. Whatever the changes we are doing, it's purely on the system, local host.
Okay.
But it's going to be the same feature. See, only when you perform the same on the production environment, right? Instead of localhost 9090, your Prometheus server IP will be here.
Understood. So what about the different approach? Suppose we have a Git, we push changes, we suppose we have a pipeline for our Prometheus deployment. Okay. If you
Mhm.
make some changes, we can pass it through the Git. So in that case, we should follow this reload feature or direct pipeline. We can trigger it so all the changes will get into your server. What you
See,
can say?
whenever you are doing the Git pipeline changes, right?
Hmm.
If your pipeline changes has the changes with respect to YAML as well.
Hmm.
So what you will be doing, you will be instructing like, okay, deploy the changes with respect to the YAML as well, right? You're clearly mentioning in the pipeline what all
Correct.
changes has to be done. Along with that, you will have to mention the reload as well, the reload process as well. You can simply use the Prometheus server with the port
Hmm.
and reload. That's it.
Okay.
And
Okay. So there
once
will be no conflicts, right?
no
So
conflict. That's why, see, already what we have what that's why we should be keeping the files in a root.d directory is to avoid the conflict only. So if you are doing the changes over here, it should be in a kind of locked state. You can use any kind of a S3 bucket or so, or any kind of like for Prometheus, for Terraform, we have this state mechanism, right, where we can keep the files in that format to avoid the conflict. So similarly for Prometheus rules, you can implement the same process, wherein if you are updating the lab or you are updating the lab files or YAML files,
hmm.
only you should be able to do it to avoid the conflict.
Okay, okay. So suppose this is the interview question, how we can use
Mhm,
a reload. So I
mhm,
can say we can reload the pipe, reload the command, you can use it curl reload,
mhm,
and it will take the changes from your local to your
mhm,
server. Okay,
mhm.
that is fine. So what is the mechanism behind it? Can you give me one example, very simple, so I can
Mhm.
be ready with an example. What is the mechanism behind the reload?
Okay, see, um, it is, see, this is nothing but you are forcefully instructing your server,
Hmm.
okay, to pick up the latest assets. To reload the assets is here. See, when we deploy any kind of changes, correct?
Hmm.
When we refresh it or when we restart it, what
Hmm.
exactly that happens? That instance will get will shut down and it will start with the latest assets. It will
Correct. Start with the new instance, right?
that is the new instance altogether. It's a new instance.
Hmm.
But if your application doesn't require a complete new instance at all, your application just need to take the latest or to refresh with the latest changes. In such cases, this reload functionality usually kind of take up the changes, and it's internally pick up all the changes. We no need to have a separate instance for this one. It's running all the time. It's just you are forcing your server to take up the latest changes. But
Understood.
what all
But
kind of changes it will pick up? It doesn't have the requirement with your no need to have the connectivity with your JVM and all, right? It's the static changes. It's just the static changes or the YAML changes that it has to pick up. So it will pick up this changes.
okay. Got it. Got it.
Mhm. So when you're doing the using the CI/CD pipeline, right? When you're implementing, and if your application has these changes, you just to need to make sure that along with the YAML file changes, this reload features also has to be. See, some YAML files require a complete restart, whereas Prometheus has this feature like no need of this restart. You can simply perform the reload activity over. Okay.
Got it. Yes.
Yeah. So now we will reload this feature, the changes that we have done with the localhost 9090. We are informing Prometheus server to take up the latest assets, take up the latest changes. Okay, just run this command. I will pin that command here as well. Yeah, please run the reload for 9090 as well as for 9093. Why we are doing for 9093? We are informing to the alert manager as well. Now you can see we do not have any other rules apart from the standard from the rules.yaml. Okay, since we have done the reload, we should be able to get the lab related rules as well. Please check if you could see these lab1.yaml file over here. I think you should be able to get the
Yes,
same.
we can see.
Please check if this alerts are getting firing up. Is it working, guys? Is your application Prometheus server able to pull the lab1 YAML file?
Yes.
Okay, thank you. So as you can see, these alerts are firing up now. Why we are seeing these alerts? Let's check this out. Okay, so latency is more than 500 seconds, 400 seconds. So that's why error rate and all. Okay, fine. So yeah, Anirudh, I was just checking this process, right? I was not able to recall the exact name. I was saying the Apache name, right? So it's not Apache. It's a web enable lifecycle. So it's a standard HTTP process actually. It's a built-in feature. So for your web application, uh, kind of like whenever there is a we do this curl command, right? If the web server is accessible or not with using the HTTP command, standard command. And if it is accessible, we get the 200 response,
Mm.
isn't it? So if it is not accessible, we get a kind of 400. So it's kind of a built-in web application lifecycle, right? So similar to that web lifecycle, it's a kind of reload is also part of it.
It's a part of web life cycle.
Web lifecycle only. So what exactly we are doing? That's why web lifecycle is nothing but for which you no need a proper instance to run, a Java instance or any application instance to run. It will just pick up based on the location of the file that you have set up. If it has the static files, it will pick up the same. And if it has the YAML file, it will check if your YAML file is proper or not. If it is proper, it will take up the changes.
Okay. Okay.
Yeah. I was not able to recall that terminology, web enable lifecycle.
Web enable life cycle. Okay.
Yeah. Okay. So now the next thing that we will be doing is now you could see these alerts are getting fired up, right? So the next thing that we have to check is if these alerts are properly, if your the channel, the Teams channel or whatever the communication channel that you are having, if that is getting properly initialized or not. So as you can see here, just check on the localhost 9095. You must be seeing some alerts loading over there. Just check that out. If you are also seeing the same alerting that I just now, you could see the on the Microsoft Teams. Uh, we will be pushing the alerts from Alerts Manager to Teams in this format. Please check with the localhost 9095, guys. If you are able to see all these requests, and we have set up this request, right? Lab high error rate and lab the slow request. So both of them are getting triggered over now, as you can see. And whatever the runbook that we have configured, we have discussed, right? So it is getting triggered in the same way. Please check if you are able to access this application. Localhost 9095. So as we discussed in this today's this architecture diagram, right? What exactly it is doing now? We have done the changes over here. If you could see, we have added this YAML files, right? Lab high error rate and lab slow request. Correct. We have added this into the alerting rules engine, right? And post that we have done the reload. Once we have done this reload, your Prometheus server has picked up the latest changes, and when these alerts are fired up, like when these alerts are true, it has informed to the alert manager. Now this alert manager has checked, and it has informed to the uh, respective receivers or the endpoint. Okay, so the same flow is right now it is working in action. If you can see lab at higher rate, it is informing to your alert manager. Your alert manager is informing to 9095. This is 9095. Okay, so just check if it is if you are able to access it. Now, as you can see, the severity of the application. Okay, we have set up the rules, right? If my severity of my application is severity 3, if there is a latency, we no need to call out to anyone, right? So what exactly we are doing over here, you can see we are just simply creating the ticket, correct? Uh, okay, now there is a one more alert. As you can see, there is a critical alert over here now, correct? The severity of the application is critical, and the earlier the severity of the application was warning, correct? So now you could see the both have triggered now, and um, it is informing like call out, on call, call out, SRE call out, correct? So this when this alerts will get triggered, the SRE on call team member will be called out by the respective TCC or the triage team. If there is a kind of a warning alert, so they will be simply creating the ticket on your behalf. It's a kind of S3 severity 3 level of incident. So they are not going to call you out. So it's kind of simply creating the incident. Any doubts or any queries, guys? This is the same, process that we will have to implement on the production environment as well. Based on the application criticalness, we will have to, as in our session, we have discussed about the severity of the application. If it is a severity 2, then we are reaching out to the on-call member, correct? Not on the call, but it's a kind of they are getting notified over the Microsoft Teams or whatever the alerting in place. If it is a severity 3, then we are just raising the tickets. Okay, and for that process, I will show you how we need to implement that in the for the Microsoft Teams. What is the webhook configuration that we have to set up? Okay. Application.
Santosh, I have one question.
Yes, Ankita, tell me.
Yeah, so whatever the alerts that we want to configure, we need to do it in a YAML file itself.
Yes, it has to be done in the YAML file. Yeah.
Is there any way to do it in UI level?
See, on the UI side also, that can be possible. Okay, we can do it at the UI level as well. But the thing is, again, as we said, as Aniruddha pointed out 2 minutes ago, there could be a chances of conflict. At if we try to change the same YAML file, and if you are given the access to multiple people, then they try to change the YAML file at the same time, right? There could be a chances of conflict in the alerting mechanism. Then. Yes, we can do it. There is a again tool called Mimir. With that Mimir tool also that can be possible. There are multiple tools available for the production configuration. Again, it has dependencies, but it's always advisable to have a separate YAML file for your production for your whatever the activities you are doing. But yes, it can be done from the tool as well, UI side as well.
Okay. And in one YAML file itself, we have to write all the alerts.
Not
I mean,
necessary.
not
Not
necessarily.
necessary. You
Because a
just
different team, I mean, different
correct.
team has different requirement.
Exactly.
And
Exactly. Now
yeah,
here you could see, sorry to interrupt you here. We have done the lab1.yaml file, right? Now let's say your payment application team is using payment.yaml file. Now let's say there is a wallet team. So they for them you can create a wallet.yaml file. Because in the Prometheus configuration files, what we have defined over here, just read the all the files which has star.yaml. You can see this here, right? It is reading all the YAML files. Just we need to ensure that whatever the rules I am preparing or I am writing, it is in the YAML format, and it has a proper YAML format. It should be in a proper indentation format. It should be a proper one. Otherwise, it won't be able to read it, and the reload may fail. Sometimes you might have seen in the production environment you have done some changes, but the changes are not getting picked up. It's because of the wrong indentation within your application. We need to make sure that whatever the YAML changes we are doing, it has a proper indentation.
okay. And
Yeah.
let's say server, I mean, there are group of servers, like 5 6 servers, and that we need to
Mm-hmm.
monitor.
Mm-hmm.
So so rules are server based wise, or we can do it as a grouping also we
Yeah,
can.
that's the next lab we are going to discuss now.
Okay.
Now, let's say if your application has 50 servers and you are performing the maintenance activity for the payment application. Now, if it is there is no grouping mechanism in place, you will get all the 50 alerts for 50 servers. But if you have the proper grouping mechanism, instead of 50, you will only get notified once that your payment application is down, like that. So we are not reaching out to the on-call person for all 50 alerts. We are grouping them.
Yeah.
Okay.
Yeah, yeah.
Yeah. Okay. Any other doubt, guys? Any other queries?
Hi Santosh, can you hear me?
Yes, Mukul, tell me.
Yeah. So, there are two questions from my end. First is, mm, what is the difference between the alert that we created on UI and the alert that we created through YAML? So, my point is, whatever alert we are creating through YAML,
Hmm.
so can we view that on UI or vice versa?
You
Uh,
can you can view. So whatever the alert we have written or the
okay.
lab YAML changes we have written, we are validating that over here, right? It is getting reflected. You can
Okay.
access that in the alerts as well.
No, in Grafana.
Yes. So the
Uh,
main difference over here, let me quickly show you that part as well. What exactly the difference over here is. Now, if you see the Prometheus server over here. So what's the main functionality of that? We have discussed about this, right? So your Prometheus server is nothing but processing your metrics and log data, a metrics data over here. Now there are two types over here. If you are using the Grafana as your like source of truth, like visibility and all the operations point of view, if you are purely dependent on the Grafana, then alert manager will not come into the picture, because
okay.
your Grafana will take consider the metrics, right? Whatever the metrics it has received from the Prometheus, and based on that you are going to create the alerts. Whereas Prometheus server is pushing the alert to the alert manager. Again, it is a kind of service that is provided by the Prometheus only, alert
Mm,
manager. Now, why they have provided, why they have, implemented this alert manager process is is like you no need to rely on any other tool like Grafana, Datadog, or any other tool to configure the alerts. If let's say if you have to solely go with the if you don't, your application doesn't need a visibility part, visualization and observability. You but just need a kind of alerting in place for your application. So for
mm,
that, you no need to go with any additional Grafana or Datadog tool. You can simply use the alert manager service and you can create the alert.
okay. Mm, yeah.
Okay, so that's the main difference. And yes, from the Grafana UI also we can create the alerts. Okay, As long as your Grafana is pulling the records or is getting the records from the Prometheus server properly. Now let's say what's the main issue that I'm just to concern, one of the concern that usually we get into it, like we on the production setup we get. Let's say there is a lag in between your Prometheus server and Grafana. If your Grafana is not able to pull the records or get the records, if there is a lag of 5 seconds or 10 seconds, they are not able to display the data in the visualization, the same impact will happen to your alerting process as well. Because there is no data, your alerting manager will not able to process anything, and it will consider as a inactive, even though there is a issue. Whereas when you are using the Prometheus server, it is continuously pushing the data to the alert manager, correct? And your alert manager is processing it, and it is like based on your rules, it is sending out the alert. So it's a kind of additional check that you can configure. It's a kind of additional alerting process you can configure within your application.
Okay. Okay.
Nowadays, as you rightly wanted, like we can do it from the UI. Grafana is also supporting from UI. You can directly configure your Teams DL, from where that will directly pull out the. I mean, it will send the report to your Outlook as well. Datadog is also capable of it. Most of the tools are capable of it, because alerting is a feature, like by default feature is provided by most of the observability and visualization tools. But this feature is like alert manager. It's a part of the Prometheus only.
Okay.
So whenever you are going for the interview process, right? So when they ask, like when they start with the interview process, when it comes to the Prometheus, if they are mostly dependent on the Grafana tool, then you are good to explain like how you can set up it from the Grafana, the alerting part. But if they are purely looking for the experience from the Prometheus and how your Prometheus server is connecting to the alert manager and how the alert manager connect with the respective end users. If that process is required, then again you should be aware of this process as well. That's why.
Okay. Okay.
Hope
And
it is clear.
yeah, it's pretty clear.
Hmm.
Thanks, Santosh.
No
And considering Kubernetes architecture, okay. So I mean, I got confused. I mean, where would these alerts file would be? I mean, will it be on Prometheus server or somewhere on the
Prometheus server only.
Prometheus server,
Prometheus server.
right?
Yes.
Okay, okay,
Everything will be on the Prometheus server.
okay.
It is just the target. Here it is the target is payment app. For Prometheus, it is going to be for Kubernetes, it is going to be a Kubernetes cluster.
Okay.
From there, your Prometheus server is going to pull the records.
Okay,
It is
okay.
just the change of the source. Like that's why I kept it as a payment app. Here, whatever you come up with, let's say you have Linux box, you have to install the node exporter over here. Again, once your node exporter is ready, Prometheus will start pulling up the records.
And
tell me.
yeah, I'm sorry to cut you. So that part will you be covering in Kubernetes? I mean, how to do that and
Yes. I'm
yeah.
setting up that as well. See, as
Okay.
of now, I'm exploring both approaches. Okay.
Okay.
Like how I can, I have installed the kind, and I'm just checking if my Prometheus server is pulling up that record or not. Just trying to see, the thing that I'm trying to implement here is not to show how the architecture works, but to actually, when your Prometheus server or pod is crashed, how it is going to reflect on your server, and that thing I wanted to this show. So that's why I'm checking how that can be displayed on
Okay,
the
okay.
so
Yeah, but
that takes some time, but yeah,
yeah,
I am
okay.
covering that.
Not today, but later when you will cover
Yep.
it. Okay, okay, great,
Yes,
great.
I will be covering that part. Yep.
Okay, cool.
Yeah.
Yeah, thanks, Santosh.
No worries. All right. So I think we are done with this, at least creating the alert, right? At least like with the lab session, and it is working for each one of you. So I'm moving on to the next part now. Okay. So mostly we no need to run the chaos, since that we are getting this chaos runs, like once we start it, it will generate a error traffic for us, and already we are able to see the errors and everything being displayed properly. So we don't need to run the chaos as of now. Okay. So these alerts are already been active, right? So we no need to create any additional chaos testing over here. It is already been created. So it's getting fired up, and you could see here, correct? Just that's why I did not run the chaos one. Okay. Now someone asked about the grouping mechanism, right? How this grouping works, and at the alert manager level, right? So So this is how the grouping is configured, right? So if your application has 50 servers, so if you see here, um, again, like for the payment service, we are creating one group over here. And if for your payment service, all the 50 server has high error rate, it is considering as a one group. It is not creating the 10 different alerts. It's creating a single alert for your application. Okay, now based on the type of the error and based on the type of the service, it is creating only single alert. Hope I think Ankita, you have this out, right? About the number of errors.
Yes, yes.
Okay, now you could see here, payment app has two different types of error. One is high error rate and the payments API elevated error. And we could see the payment API high error rate. Okay, so why we have these many kind of errors over here? Every alert has a different like the purpose to serve over here. Okay, now if you could see, the payment API error rate is like the error rate that we have configured. If it is a severity one, right? If it is kind of high severity, it is going to be severity 2. It is kind of informing to your team on call. Now if you see lab high rate error rate and payments API elevated error, these both are nothing but the same alerts only. Just like we have enabled the lab today, it has created one more group over here. But if your all 50 servers have the same error rate and all servers are down or with any issues, it is not going to create all 50 alerts. It's just considering in a single group, and with that it is sending the alerts.
And what if in the real scenario, if I mean under the 50 groups, let's say one server is down, then how it will work?
Again, it will a single alert. It is purely configured on the basis of service name. If your service name has one server or 100 server, doesn't matter. If there is a error, it is going to send out the alert. It is just avoiding the number of errors, the number of callouts. If all 50 are down, it is not going to send out all the 50 alerts. It is going to send you only one alert saying your payment application has some issues with this alert name. And we could see that in our Teams channel, right? So this is how it will show. And once it is resolved, once let's say your application is back to the normal state, again that alert will get into the resolved state again.
And let's say if one server is down, so
Hmm.
you will receive the same alert
Yes, you will
mentioning the
receive.
server name. I
Yes,
mean,
yes, 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 yes. We will receive the same mentioning the server name.
and for let's say all the 50 were down.
Hmm.
So did we receive the information like all the 50 were down?
Yes, you will get a kind of a complete. Now, if you see, if your alerting is not proper, if you are not grouping them, you will get this kind of error: alert one, server one, alert two, server two, like this. But if you have multiple servers running over there, if they all are down, in a single alert, in a drop down, you will see what all servers are down. That will club all the, that will group all the failures in a single notification. That is nothing but the grouping.
Okay,
I
but
will show you
that's
that.
that's the one thing like
Hmm.
okay, this is one kind of alert. Let's
Hmm.
say some servers threshold is different and some servers threshold is different.
Hmm.
Then how it will work?
See, even if it is any value for your threshold, whatever threshold you configure. Okay, so right now, whatever configuration we have done, what we are saying over here is it's a high error rate. Now, when you set up the threshold, your error or the application threshold that you are going to set up is not kind of into, it will not fall into the grouping process, right? It will fall into the alert process. Okay, the Prometheus alerts that we have set up, correct? Now I will show you that part as well in a second. We have this Prometheus. Sorry. Yeah, this one. Let me show you the production copy. So the threshold values for your application. Now, when you set up the threshold for your application, you will have to prepare a new alert over all new alert over here, right? You no need to perform the grouping. So what you can do, if you could see over here, you can club multiple threshold in a single application, in a single alert. Now you could see here, payment SLO. For the payment application, if for my service, there are multiple applications and having the multiple thresholds, so I will create a multiple alerts. So based on that, it will club. Based on the type of the threshold, we need to create the alert, no?
Yes.
So as you can see, for my payment app, we have created multiple alerts over here. Payment API slow, payment API is down, right? High memory usage. So you're saying about the threshold, correct? So this is nothing but the threshold alert we have set up. Now, what we are setting over here, if the memory is 90%, okay, host memory is 90%, then it will trigger. But for your application, if you want to set up multiple alerts, if it is more than 70% or so, you can simply create a one more alert. But what it will do eventually, it will consider a single alert when when it get triggered, it will consider as a single application only, because we are configuring this alert on the basis of groups. Correct. So again, so how it will get triggered? It will for, let's say you configured it for the more than 70% for your application. It will check the type of the severity. It will check the service, who is managing the service, and which team is maintaining the service. Based on that, it will create the alert.
Okay, got this.
Yeah. So even though your requirements are different, though it kind of a memory, or though it kind of a disk space, whatever it is, it's that what we can say, that check that we are going to implement on the rules.yaml. The grouping comes into the picture once your rules are implemented. Once your rules are in place, then you are clubbing the number of then you are clubbing the all the alerts in a single alerts in a single group. Sorry.
So multiple, let's say we have multiple teams and I've
Mm,
created multiple YAML files, each
mm,
respective team.
mm.
Then should we have that rules file only one, or we can create a team wise rule file also?
Team wise, it's always recommend to have a team wise YAML files, rules files. It's always recommend. So because like the rules that you are applying over here, right? It is different for all the organization level, right? Payment will have the error ratio. It's kind of, their application is kind of going to be critical all the time, but not necessary that the valid team or the any other teams will have the same kind of SLIs in their application, isn't it? They will have some kind of less SLO. Like right now, payment is 0.5, right? For let's say any other applications, if they are not that critical, they will set up the alert for, let's say, 1%. They are okay with 99% of the availability. So for that, they will create a YAML file with their SLIs. So that's why it's always recommended to have a separate YAML files for your applications based on their functionality.
Okay.
Yeah. Hope it is clear.
Yes, it is.
Okay. Yeah. All right. Okay. So moving on to the next part, as we were discussing about the grouping process over here. Okay. Now, I believe so. As you could see, this alerting, if the alerting is not in place, like let me show you the alert manager conf file. We have this alert manager process, right? Service running over here. So in that, we have already implemented the grouping process as well, correct? So let me quickly show you that. That's not the rules.yaml, alert.yaml. Yep. Okay. Okay. I think we have discussed about the routing process as well, right? Based on the severity, how the routing works, and that also we are able to see that. For that, we no need to create the chaos testing. It's already we are able to see that on our 9095 port. Okay, now as someone was okay, we were discussing about this Mukul, right? For the 20 Kubernetes pods, how that works on the application side. Now that's this is the same terminology. Like instead of combining, having the multiple individual alerts for your application, like server one, server two, like we can club them in a single group. Okay, it stopped the overall alert storm, right? If there are 50 servers and you might get a 50 odd alerts and unnecessarily when there is infrastructure maintenance or any kind of activity going on, right? And like let's say like again the 20 Kubernetes pods we have behind the LB, and suddenly there is some activity going on over the weekend for the database activity, and which has a due to which like your database instance itself crashed. So your all 20 pods are not going to work and they will be throwing the errors. Now, if you have this pager alerts and SMS managers and Slack alerts in place, you will all get the 50 kind of 20 kind of alerts, right? It's kind of going to be an alert fatigue. So that's why the grouping usually works for your application. That is always recommend to have a clean one summary notification for your application when you configure the grouping process. Right, so what we have done in this grouping right now, so if you could see this alert manager conf file, sorry, alert manager YAML file, as you could see, what we have done over here is, so this is nothing but the resolve timeout. So again, similar to the script time is 15 seconds, right? So similar to that, we have this resolve timeout, like the alert manager, usually it will check in every 1 minute if whatever the alert got fired by the Prometheus, is it valid or not. There could be some kind of issues or some kind of lag or some kind of connectivity issues may happen. To avoid such kind of issues or instances, what usually alert manager does is uh, it, it it checks in every 1 minute or so. Again, it retries. Okay, and if it is able to still if we're still able to see the issue, it is still issue still persist, then it will initiate the next process. Okay, now what we have done over here, this is the nothing but the routing process and grouping process over here. So what we have done, the severity of the application, as you can see, critical application, the receivers are going to get the teams on call, and again, it is nothing but the groups wait call. It is similar to what we have the interval set up for to trigger the next alert. It will wait for kind of 2 minutes, right? And again, if the teams, as Ankita, you said about the how if my application has multiple dependencies within a team, right? So what they can do, they can simply have their matches. So if the matches is related to the payments application, the team payments team conf will get initiated in the teams. If it is related to the platform, so here this is how you can do the routing instead of creating a common portal where all the alerts will get triggered at the one place. What you can do, so let's say there is issue with the platform. So if you do not create a proper routing in place, what will happen eventually, payments and platform, both teams will get a single alert. Even though it is related to some other teams, they will keep on getting the alerts. That's why it's always recommend to have a proper routing in place. So we have seen this in our application, right? So we are getting the alerts whenever there is a platform issue. Platform alert is getting triggered and the payments platform team is getting notified, right? So this is the process. Now I was discussing about the how to set up the alert for the Microsoft Teams, right? So this is nothing but the webhook console. Okay, you can use the same webhook console as is in your configuration file. Okay, even in case if you have to set up the same for your in your organization, which connects to your Microsoft Teams, and that will initiate the Teams on call, or it will connect to your Microsoft Teams and it will send the alert. Okay, so when it comes to the grouping process, so we have, if you can see the group, what we have done here is this is nothing but the group by. Okay, so in database we have this group by, or in Linux also, Unix also, we have this group by feature, right? So what exactly it is doing, as we have seen, alert name and service. So let's check this out, how exactly it is getting triggered. We have this right, group by trigger. Yeah, correct. So based on what we have, we are checking the group by, it is alert name and service, correct? So the same process by alert name and the service name. Based on this, your alert will be grouped. If there are multiple alerts for the single server, all servers will be listed down here. So Ankita, you could see over here, right? It is a single source. So you can simply check over here in the description, all the servers. Oh, sorry. Okay. When you click on the info here, right? So if you have multiple pods from the same application, if they crashed at the same time, you can get the information over here, like this. Everything will be, I mean, as of now, we have only one instance, right? So it won't be able to show you that complete details over here, but once you configure it for all your services, you will be able to see the complete details, right? It is not able to fill this up. Okay. Nice. Okay. So this is the process for grouping and routing. Okay. So the next thing that we are going to implement is to check if the grouping is working fine or not. Right now the grouping is working as expected, but we will change the grouping logic. We will remove the grouping logic, and instead of grouping all the instances, we will separate them and we will reload, and we'll see how the alerting is working. Okay. So what you can do, you can simply open the alert manager, this file, right? Alertmanager.yaml file, and we have this uh, alert name and service, correct? So just simply remove that. So alert name and service group by, and just keep three dots. It is kind of a default configuration. It is not going to group by with any service or anything like that. By default, it will, whatever alerts you will get, it will generate all the reports. You can try this out. Just change the group by clause in alert manager. Okay, with this one. Let me change this in the chat box.
So these are the whatever the alerts that we have mentioned in that YAML file, right?
Hmm.
So all the alerts will be get generated.
Now with this, right, if you do not group configure group by, if there are multiple pods or multiple services, it will generate alert individually. So if there are 10 pods are crashed, you will get 10 requests, 10 alerts rather than a single alert. So with this, you will get it will club the alerts based on the alert name and service. When you uh, remove this proper check, irrespective of the logic or irrespective of the alert, it will trigger it and it will send out the alerts. Though it is a payment, though it is a platform, it is not going to check that. It is just going to shoot out the fire the alerts. Whatever alerts it get from the Prometheus, straight away it is going to send it to the alert manager.
So which one is better, Santosh? So should we keep group by or individual, or it
It's
depends on the situation?
it's always, see, if based on your application. Okay,
Okay.
if your application has not much dependency, let's say I'm a part of database team wherein I don't need, there are only limited database instances, I won't be required the group by over here, right? Because I know, okay, there is this database, only 4 or 5 servers are there, and for which I no need to go with the group by. But if you're managing the Kubernetes clusters, right? So if for that, if you are planning to have I mean, if you're looking for configuring cluster wise, now if now here we have sent configure with the alert name, right? So now let's say if you're managing a Kubernetes cluster, okay, or you are managing the multiple production environment. So how can you do that? You can simply let's say you are managing the prod one, okay, then you can manage this prod 2 like this. So this alerts or let's say the cluster 1, cluster 1 or cluster 2, correct? So based on that, it will be clubbed. Based on
Okay.
the type of the group by you perform over here, those alerts will be clubbed. So right now, let's say if I am performing the blue-green kind of deployment, let's say I'm like kind of I'm shifting the traffic from one data center to other. Now, what will happen like when if I have to bring down the complete cluster, or if I have to bring down the complete set of servers. So if I have the proper group by, I no need to worry about how many alerts I will get. I know like I am going to get only one single alert based on the group by clause that I have implemented.
Okay, okay. So that means, for example, if we are considering blue green only,
Yeah,
blue is current one and green is new one, right?
correct,
So yeah, so I can ignore the alerts for the blue one,
correct.
and I can check alerts only for
Only for the green
green
one.
one. Okay,
Yeah.
okay.
So
Likewise.
why this feature is important? Let me give the another benefit of this one. Let's say if I have to, I don't need any alert. I know that its cluster 2 is going to be under maintenance for next 5 hours. I don't want any kind of alert. So when I
Hmm,
perform the group by, I can simply silence a complete cluster 2 related applications or cluster 2 related alerts from the alert manager itself. I no need to monitor them at all because I know anyway they are going to be under maintenance. I
hmm.
can silence the alert based on the cluster also.
Okay, okay. And mm, for example, let's say cluster 2 is under maintenance and cluster 1 alert I'll be monitoring. Okay,
Mhm.
but under there are multiple application pods, right? One is having applications, one is for database, one is for another purpose. So pod specific segregation or that grouping also we can do over here. I mean, or
Yes, yes,
yeah.
any
Okay.
kind of mechanism, like whatever convenience, like based on your, if you want to do it on the pod specific, if you want to do
Hmm,
it on the cluster specific, if you want to do it at the node level, right?
hmm, hmm,
Any level, like you can configure it. It is just a kind of a grouping that anyway you are going to informing to the alert manager
hmm, hmm, hmm.
that
Okay.
how you want to set up your alerting, how you want to group by your the alerts. So if you
Hmm,
want to group by your alerts, like let's say you expect a flood of alerts from cluster 1, based on the requirement again, like it changes team wise. Like let's say if my maintenance activity is only limited to the 20 pods, then I will go with the pod by group by pod wise, right?
hmm.
With the application only. If my maintenance activity involve a complete cluster, then I will go with the cluster wise group activity query.
Okay, okay.
It is
And
dependent on the
how
requirement.
how the syntax would be here? Multiple group by clause or in single only we can do that?
Single only you can. Right now
Okay, okay.
with this, say
Uh,
whatever you configure over here, it will reflect the same over here. So you can see
okay.
this here, right? Now
Hmm.
what we have done, we are earlier like we have set up with alert name and the service name. But you
Hmm.
want to
Hmm.
keep, let's say you are managing, let's say you are a part of only payments team. You don't want to take care of other, don't want to worry about other teams. You
Hmm.
can simply give the service based on the service name.
Okay, okay. Hmm.
Again, based on the type of the alert also you can configure. Let's
Hmm.
say if you want to create a group by based on the latency, if you want to create
Hmm.
it based on the error rate, so that also
Hmm.
it is possible.
Yeah. So like lab slow request for service,
Hmm.
lab slow request for payments or lab slow request for database, lab slow request for other any application, something like that. Service,
Correct,
I mean.
correct.
Okay, okay,
So based on that, you can
okay.
modify based on your requirement. There
Hmm.
isn't any proper, that's why the group by beauty of the group by is it support all kind of your requirement based on
Hmm.
the type of your application you are working. Based on that, you need to change the group by class.
Hmm. Okay.
And based on that it gives you the results and you can configure accordingly. Now
Okay.
when you configure with I mean when you give this kind of remove this feature like condition, what it will do, it's a kind of, it is not going to do any kind of group by clause over here. Even though it is like you are performing on cluster 1 cluster 2, it is not going to check that particular thing. It is going to send all the kind of alerts, whatever alert it gets from the Prometheus server, it is going to send. Okay, so this is nothing but now we have just changed this with the triple dot, and just now we have done this on the alert manager, right? Alert manager instance is running. So as you know, alert manager is running on 9093. So we need to perform the reload on 9093 as well as on the let's perform on both 9093 and 9090. Okay, let's do these changes, guys, on the alert manager YAML file and run this reload. We have to perform the reload on both 9090 and 9093. I will take 5 minutes break, guys. I will be back shortly. In the meanwhile, if you have any queries or any questions, just post in the chat box and okay.
Santosh, I have one question.
Yeah.
Like, we need like we if the alert severity has a warning
Mm-hmm.
severity, okay. So I want warning alerts to be sent out to my email and high alerts to be sent out to Grafana. So those things also we need to do it in that alert manager YML file.
Okay. So you want high alert to be sent on Grafana.
Grafana on call, like that's a high alerts, and
Mm-hmm.
warning will be sent out to email. It's low priority. We can log in and then let it check
Yes,
likewise.
yes, absolutely. That can be done. It is again how you want to set up your again like this process we discussed about configuring in the alert manager, right? It is nothing but the same. We need to change. So let me show you that part as well. We have this file, right? Alert manager file. Okay, so
Yes.
in alert manager file, if you change, like if you want to keep the alerts only specific to your email that you want to send, then that can be achieved over here, like that also. Now we have what exactly we are doing, where is that, is 9095, okay, this one, teams, right? So this is the configuration block. Okay, this is like we have set up for Microsoft Teams. So instead of Teams, you can simply implement the same. You no need to implement that as well, since like your Grafana is already pulling the record. Your Grafana is already pulling the metrics and the local logs, right? So whatever the logs you can set up, you no need to implement those things in Alert Manager. You can remove those changes from the Alert Manager. And what only the things that you want to send the email, you can keep in the Alert Manager configuration. Your Grafana 3000 is running, right? Let's check that out. I will show you that as well. Just log into the Grafana instance, and I will show you. You no need to log in. I will show you. Don't worry. So here there is a alerting rule process is there, right? So based on the alerting rule, like how do you want to configure? Again, so from the UI part, like how that can be configured, as you can see here, based on the type of the alert, or as you mentioned, like the criticality of the application, right? So based on the type of the alert also we can configure. Now what exactly we have to do over here is the type of the alert. So let's say if I select Prometheus over here, correct, and the Prometheus metrics, you can no need to refer any dashboard over here. So what you can do, like this is firing now. This is critical alert over here, right? So you can configure, like select this severity based on the severity of the application. You can configure the alert. Now this is the rule that we are setting up. We have discussed, we have created the groups in Alert Manager, right? So similarly, in from UI side also we can create. You could see there is a group option for here, right? So you can create a groups for your application, and based on that also you can create the alert. Okay, and when you say that you have to send a Grafana alert, then again these are the policies you can set up based on the notification policies. I will show you that part as well. My Grafana rules, yeah, the tools. Okay, now here, now as you mentioned that you have to set up the critical alerts from the Grafana, correct? So here is an option called add query, right? So here what you can simply do, you can simply add the critical query from the builder also you can create, and we have discussed this in previous sessions, right? You can add your critical queries over here. And
Yes, yes.
once you create a critical query, right, based on the severity, save this rule. This rule will be created in your application, and from this, once this rule is created, you can simply have this. You can simply use this rule while creating the alert in the alerting part. So for that, like as I said, if you are planning to create the alerts from the Grafana, first of all, you need to create the rule, and that is again how do you want to define it. If you want to create it on the basis of the severity, then the critical alerts and all this you can define in a single rule. and based on the rules, you can create a groups. You can create a alerts. These are the alerting rules, and based on that, you can create the contact points, and that is how you can configure it from the alerting point. So as you can see, this is nothing but the grouping process. Here it has, they have shown the grouping process as well as. So instead of sending all the 50 server alerts, it's kind of it send out a single alert. Again, like it depend upon your criticality and depend upon the type of the application you are working. And based on that, you can set up the group.
Okay.
Yeah.
So in that alert manager file, the YAML file, that Microsoft one that you have commented out, right? So
Mm-hmm.
it should be uncomment if we want to use that.
Correct. You should uncomment this particular block. Okay, and uh, it's kind of web. You see, this webhook URL is there, right? You need to get this webhook URL from your organization. Like you can refer the current configurations in your production environment. It's a kind of webhook configuration. Okay, there will be a kind of endpoint.
Yeah,
But
yeah, I know the URL. When
Hmm.
you create a team group
Hmm.
into your teams, it
Yeah.
has an option to create that webhook
Webhook
link.
URL.
Yes.
Correct. So you need to just update the webhook URL from
Hmm.
your teams and the required details. So it will support for your team's application.
So whatever the alerts that I've mentioned in that same file,
Hmm.
that all the alerts, if I
Hmm.
want, I mean all the alerts will be get triggered on my teams,
Hmm. Yep.
right?
Yep.
And let's say I what I've done, I have mentioned all my warning and high alerts in the same file, and I've said like high alerts to be go to Grafana. And so okay, as you said, like Grafana, you don't have to mention anything,
Hmm.
it's already
Hmm.
there in Grafana.
Yep.
So here I just wanted to mention the email or the MS
Correct.
Teams uh, configuration here only. Okay.
Correct. The only things that you particularly looking for from the alert manager, those things only you need to take care of it from the alert manager. The rest all things, like if you want to send out anything to the Grafana, Grafana is already pulling the records. Grafana is already having it from the from QL and Loki, right? It has already the data source. It is just the thing that how you want to configure it. From the prom QL, you can write a critical query. From there, it start pulling up the records and it will send out the alerts.
So as you said, like Grafana has all the data,
Hmm.
data source is the Prometheus,
Hmm. Hmm.
but I need to go there and create the rules, right, to
Yep.
get those alert triggered
Correct.
first.
Correct. Yes.
Okay.
It's see, thing is, any tool, though it's kind of a Grafana, though it's like if you are using any other tools, Kibana or no, or any UI visualization tool, Datadog or anything like that. If you have the data source as a Prometheus, you will have to create a PromQL query, the rules over there, and based on that rule, the based on that result, your visualization is going to run that query, and if it is a success, then it is going to fire the query. If it is not, then it won't. It will be in the inactive mode only. Whatever the alert manager process that we are discussing, the most of the UI tools are functioning, are already providing that feature. Most of the UI tools, Grafana and all these things, they're already providing. It is just like the thing is, like if you do not want to rely on particular visualization tool, if you don't have any dependencies with them, just to set up the alerts, if you have only the Prometheus in place, using the alert manager, you can set up end to end. You can create a PromQL dashboard as well, and this alert manager. From that, you can set up the required, based on the requirement, you can create the rules and groups. But most of the UI tools are already been supporting this one. Tomorrow, as I said, like as we discussed in the last week, right? The middleware team. So I had got the approval from them. So they will be giving us the KT or the demo session, how the tools exactly works on the production environment, the alerting process, the synthetic part, everything they are going to give us the demo on the production environment. It's a kind of a sandbox environment, but yeah, they will at least able to show us like how that exactly works. It's at 11 o'clock, same time, guys. So and probably it will take an hour or so to have a complete demo. And I will give you the query as their portal URL name as well. So this is yeah. Uh, monitoring. Mm, one second. I think last week only we had a demo. Okay, middleware data. Okay, this one only. Yeah, so this middleware.io, they have multiple features like full stack observability with AI, SRE agent, and all these features are supported. Okay, they have this installation doc as well. Okay, everything is there. And who all are there, like teams are actively using their application. Okay, so everything is there. I request you to go through it and come up with your queries, since they have implemented the AI SRE agent as well. That will fix the issue. Like they have the feature as well. Like if you click on the fix issue, it will fix the issue as well. So they are going to give us the demo on that as well. So just spend some time, check what all features are they supporting. Even I have also I'm planning to also come up my doubts and queries. So this is going to be one of like a very important meeting, guys. The demo sessions that providing, because it's a kind of new a kind of new features, a lot of new features these guys have implemented. And uh, whatever the doubts we have related to the SRE, related to the AI specifically, in your mind, like how it is going to impact to our domain, SRE and DevOps domain, and what all things that we need to learn, and how the observability play an important role moving forward, and what all things that can be achieved by using the AI SRE agent, and what would be our role in future, like how we need to evolve along with this new requirements. Come up with all your queries, doubts, whatever you have in your mind. Okay, I'm sharing this detail as well in this middle our chat box. Okay, just go through it, and I request you to prepare with your questions. And uh, actually we hardly get the kind of any appointment from them to have. So somehow they have agreed for this. So just utilize it, their opportunity. Yeah. All right. So okay. I think we have done till the grouping part. Okay. So what we will do? Will again we will my tomorrow sessions. What we will do? We will bring down the Loki instance. Okay, today we are able to complete only two of the labs, right? The uh, alerting and this process. So the grouping process we will continue with tomorrow. They have this 1 hour session only. Post that we will continue with our application. How the grouping exactly works, and this is one of the critical thing that I would like to discuss. Okay, just to give you the overview, like tomorrow, what this inhibition is nothing but again one of the process, right? So um, let's say like it's kind of along with the grouping, this inhibition is nothing but one of the process that usually implemented. So that means like if your main service itself is down, let's say your tier one service is down, the tier one service has a multiple dependencies with your application, right? So let's say your database itself system is down. So as your DB itself is down, it's going to impact your multiple applications, isn't it? It's going to impact your API gateway, payment gateway, login flow. Everything is going to be impacted since your database itself is down. Now, ideally, if we go with a standard process, like if we do not have this inhibition in place, what will happen? Every service will start triggering their alert, isn't it? Because as we know, we have the multiple teams who have the who created their independent YAML files. Now what will happen? All the YAML files will start firing up. API gateway will fire up, payment platform, all the services will start firing up, and we'll see the error like they are not able to connect with the database. But we know that the tier one application database itself is down. Now instead of getting like thousands of alerts in a minute, this inhibition is a process like where you can stop like if you have this inhibition in place, if the critical service like the database or something is down, it's not going to trigger the dependent services, alert for dependent services. Okay, so that part also we will discuss how that exactly works. So there is a inhibit rules. Okay, I will discuss that part in tomorrow's session as well, and we will go through it. And what we will do tomorrow, we will bring down the Loki instance, and with the Loki and a payment app instance also we will bring down. So ideally, if your payment container is down, uh, what we should be getting, like we should get the alerts for latency. We will get the alerts for the error rate, increase in error rate, and all those will also get triggered, right? So using the inhibition rule, we will suppress those alerts, and we will have only single alert that your target node is down or your payment API is down. Okay, and how that works, we will implement the inhibition rule tomorrow. Fair enough?
Is it something like a dependency, we can say,
Yep.
if
It's
that
it.
one alert is triggered,
Hmm.
so the whatever the dependent alerts are going to be suppressed. It's like
Yes. In this also dependency, we are considering the critical one, the tier one application. Now, the database has a dependency with multiple applications, right? So, if the DB is down, it will suppress the alerts for other services. So that rule also we will have to write. How that can be implemented, that we will discuss. Yeah.
yeah, sure.
Okay. All right. So we'll yeah, tomorrow we will what we'll do, we'll bring down the payment app, and we'll wait for some time. We'll see how that works, and we will then disable the inhibition rule. It's already there in our application. That's why we are not getting we have not yet brought it down. So we'll see how that works in tomorrow's sessions. Apart from that, the one of the critical thing that we have to discuss is about the SLO and the error budget. We will implement this feature as well in tomorrow's session. How the 14.4 rule applies into error budget, and why it is like we need to consider this error budget as like how are we calculating the 14.4 error budget, and uh, what are kind of alert that we need to set up when we notice that your error rates are increasing. Okay, we'll discuss about this use case as well in tomorrow's sessions. Okay, I think yeah, that's all I think we have for the discussion. I hope yes, this is the week 6 program. We will be deep dive into the Kubernetes part. We'll start. I'm currently working on that. I'm just trying to engage all the use cases that usually we see in the production environment, right? Like the production, the pods are crashed, and probes, readiness, liveness probes, and all. Everything that I'm working on. But yeah, we'll plan it for the next week. Okay, so I have given the middleware.io this app URL, right? So please go through it, okay, and please be prepare some whatever queries if you have any, and let's try to get as much as information from middleware team. And if you like, I mean, if your application like where the organization that you are working, if it's kind of a new organization where you are looking for implementing or to have this particular middleware tool in your application, they can also provide support to your organization to have them installed, and end to end also support they actually provide. So yeah, let's try to utilize the most of it in tomorrow's session, and please go through this URL and check what all features they are supporting. Any doubts or any queries on today's session, guys? I know we have covered only 2 labs today. It requires like more hands-on practice. Tomorrow we will cover the remaining things. And the requirements that we have discussed, right? I think Mukul, you discussed. We had discussion about the Grafana that almost like a Grafana tool is supporting, and even Ankita. The Grafana already been supporting the features, right, related to the alerts. So even middleware is also supporting those features. Okay, so we will ask how exactly they are configuring their alerts and how exactly they are the alerting works on their applications. We have already gone through these things, guys. Logs management, right? We have gone through the synthetic as well in the previous session, how to configure the synthetic. Okay, and APM also we have gone through the APM session, and run session is something new that we will get to know in tomorrow's demo session. Okay. All right. Any final queries or any doubts before we wind up today's session, guys? All right. I think we are good to conclude today's call. Then see you tomorrow at the same time, 11 o'clock, with the middleware team.
Thank you, Santosh.
Yeah.
Oh, thanks, Santosh. Yeah.
Thank you, everyone. Thank you, everyone. Thank you.